750 per hour. The equation they give you is this. H is the number of hours, and wages is for W. Which one of those would be the independent variable? Which one can stand alone? Can time stand by itself? Like, does time ever stand still?
No.
So time keeps going no matter what, right? So that's why time, hours, is your x variable. That's your independent variable. Because no matter what happens, time's going to keep going, right? Wages is your y. That's your dependent. So function notation is simply putting it in f of x form. So remember f of x equals y, right? Yes?
Yeah.
So could I say f of x equals 7.5x? What does x equal?
7.5. 7.5.
Well, that's how much he gets paid, right? And x is representing hours, right? So if he works 15 hours, I replace 15 for x, and that's going to tell me how much he made. All right. So your first word is x-intercept. Does anybody think they know what it means? So x-intercept is where it crosses the x-axis. So if the x-axis is where it crosses the x-axis, or intersects, so intersects the y-axis. And I use those interchangeably, so you could say crosses or intersects, is up to you. If you would rather use intersects here, you can. It's totally up to you.
We use crosses all the time.
It's fine. Yep. Alright, your next word, line of symmetry. So, according to graphs, anybody know what that means? Jonah, what do you think? Guess? Yeah. So basically, if you're speaking of graphs, each half of the graph on either side of the line is the same. So each half is the same. So it basically splits the graph in half. Not all graphs are going to have a line of symmetry. Okay? Only some graphs are going to have a line of symmetry. Positive function. Think of your coordinate plane. Where is the coordinate plane? Positive. If you think of the quadrants, 1, 2, 3, 4, which ones are positive? So if you think of your coordinate plane, which of those two are positive? Who's positive?
It's always the one on the right. numbers
So-
on the right side.
So 1, 2, 3, or 4.
1
1's positive.
is positive.
Who else is positive?
3.
3. So basically, a positive function is above the x-axis.
Should we write the graph down?
It's up to you. So if a positive function is above the x-axis, where is a negative function?
Below.
Below. So that would be 3 and 4. I'm going to erase my graph. Everyone got decreasing, increasing, relative maximum, and relative minimum. So for decreasing function and an increasing function, for these two, you always read the graph from left to right. So read graph left to right. Kind of the same way you read a book, right? You read a book left to right. Increasing goes, the graph is going to go up and to the right. So if increasing goes up and to the right, where does decreasing go?
Increasing. Wait,
So you read the graph left to right
for both of them.
for both of these.
Increasing goes up this way, decreasing goes down this way.
So it goes down and to the right. If you want to do arrows and like, that's fine. You don't want to write the whole thing. Yeah, you could have done down and right, up and right.
Or you could have just done like slanted line.
You might hear it called extreme. Let me fix that. So you might hear in your homework extremis. It's your highest. So maximum is like a hill. Minimum is like a valley. Everyone knows what a valley is, right? Where the rivers are. So this is the highest y value, and this is the lowest y value. Now a graph is not always going to have both increasing and decreasing. It may only have increasing, or it may only have decreasing. A graph might not have a maximum, or it might not have a minimum. So you noticed the two arrows. I'm just going to draw the bottom half of the graph. So when you see arrows like this, the graph isn't going to stop. So you see those arrows? That means the line is going to continue in that direction. So it's going to continue down. So this is the end behavior for the very, very left. I'm on the left side of the graph, right? Over here, I'm on the very, very right. Let's say this is your x-axis. This is your y-axis. So over here, would you guys agree that these are positive x's?
Yes.
And over here I have negative,
Yes.
positive, and negative. So on the left side of the graph, what do you think is going to happen if this graph were to continue to be drawn, how would you describe the ordered pairs for x and y?
If it were to continue,
Right.
well, it looks like it would probably go up again.
Well, it might, but let's just say it keeps going down.
Well, if it keeps going down, then it's just gonna keep going down in the positive. and
Yeah.
negative.
So the x values are going to approach, so I'm going to draw an arrow, negative infinity. The y values, you said it was going to be negative, right? They're going to approach negative infinity.
Infinity.
Which ones are going to go positive?
X.
Right.
Infinity.
The x values are going to go positive infinity, but the y values, what are they going to do?
Positive infinity.
Careful. It's going down still.
Oh, negative infinity.
Negative infinity still.
Oh.
Yeah, this graph is nonlinear because it's curved. So you could just say A, nonlinear. Does this graph have any intercepts? So you would look at your definitions and see, does it cross the x-axis? And remember, when you see arrows, the graph continues. So does it cross the x or y-axis?
No. Wait.
No.
Well, it doesn't stop here. The y-axis keeps going.
Then yes, it does.
So it does cross the y-axis, and it crosses the x-axis. Because do you see the arrows at the end of this graph?
Yeah.
They're going to keep going. What axis did I just cross?
Cross the x-axis.
And I crossed the y-axis, right?
Mm-hmm.
So your y-intercept is about 0, we'll say 580. Everyone see how I got that? And your x-intercepts would be negative 240, comma, 0. And then over here, positive 240, comma, 0. See how I got that one? So, does this graph have a line of symmetry? Could I fold this graph in half and both sides would match? What do you think? If I folded the graph right on this line, would this side match this side?
Yes.
Yes. So you would say, yes, a line of symmetry. Can you see that? Okay. Where is this graph being positive?
On the right side.
Okay, so it's positive over here. Is it positive anyplace else?
On the.
What does positive mean again? Doesn't positive just mean when it's above the x-axis?
Yes.
Yes.
So is it above the x-axis over here?
Yeah. It's above the
Yeah.
x-axis.
So it's all positive, right?
Right.
Yeah.
Where is it increasing?
Below the.
On the left side.
On the left side. Isn't it increasing from here to here?
Yes.
Where is it decreasing?
The other side, the right side.
Isn't it decreasing over here?
Yes.
See how it started here?
But then it's going down.
And then it went down. So it increased and decreased, right? And then is there a highest point or is there a lowest point?
Is a highest point.
What's the highest point?
Line.
Isn't that the highest point it goes?
Yeah.
And then for your end behavior, what could you say? Like if this archway continued to go past the x-axis, could you say something like you said on this side, your x's would go positive, right? But your y value is negative. And then over here, both are negative, right?